on solving quadratics by factoring. This is a lesson that we introduced when we introduced polynomials, and you learned how to factor in Unit 9. So we're really just going to be reviewing these skills. The 3 steps that you're going to follow when you're solving by factoring involve starting by putting your equation in standard form. In other words, make sure it's equal to 0. Factor, and you can either use the X method or guess and check, and then apply the zero product property in order to find each solution. So as I look at example number 1, in order to solve this, I need to know what 2 numbers multiply to negative 48 and add to negative 2. I know that for my first term, I'm going to use x and x because x times x multiplies to x squared. And then for 48, I'm going to say that I have 6 times 8 is 48. Since I want the 2 to be negative, I'm going to make the 8 negative and the 6 positive. So I used guess and check to set that up. I'll just verify again one more time. So I have x squared minus 8x plus 6x, which is going to sum to negative 2, and then minus 48. Now I'm going to apply the zero product property, which means I'm going to take each of my factors and set them equal to 0. So x plus 6 is equal to 0, x minus 8 is equal to 0, and then I'm going to solve each part. So x equals negative 6, or x equals 8. And finally, I'm going to write my answer in a solution set, negative 6, 8. Taking a look at example number 2, I'm going to do basically the same thing. Double check, look for a GCF. I don't see one, so I'm going to think about how I can factor this. Again, I'm looking at guess and check. In order to get to that first term, 2x times x is going to multiply to 2x squared. And then what 2 numbers multiply to 49 that are going to help me get 21 in the middle? And I think the obvious choice here is going to be 7 and 7. If I think about what happens when I multiply the outside terms, I have 2x times 7, which is going to give me a positive 14. And the inside terms are going to be 7x. So 14 plus 7 is going to sum to 21. So I know I have it factored correctly. Again, going back and using the zero product property, I have 2x plus 7 equal to 0 and x plus 7 equal to 0. And solving each of these quantities, this means 2x equals negative 7, or x equals negative 7 halves. And over here, x equals negative 7. Finally, write my answer in a solution set. Oh, I suppose the smaller one would be negative 7. I should put it first. Base. So negative 7 comma negative 7 halves. Continuing on to example number 3. For example number 3, the first thing I notice that this is not set equal to 0. So I'm going to fix that by subtracting 12x from both sides. I now have 3x squared minus 12x equals 0. And I notice that I have a common factor between these. So if I take a GCF of 3x out of these 2 terms, I'm going to wind up with 3x times the quantity x minus 4. And again, I'm going to go ahead and solve this using zero product property. So 3x is equal to 0. X minus 4 is equal to 0. So x is equal to 0, or x is equal to positive 4. Example 4, again, it is not set equal to 0. I always want to have my leading term be positive. So since I see 4c squared is positive on the left-hand side, I'm actually going to add 12c and subtract 216 to set this up. So 4c squared plus 12c minus 216 is equal to 0. The next thing I'm going to notice that this problem also has a GCF of 4. So if I were to divide all of my terms by 4, 4 is going to be on the outside, and this gives me c squared plus 3c minus 54. Now again, I can go ahead and factor. I'm still using guess and check here. 4 is still on the outside. What two numbers multiply to negative 54 and add to 3? I'm going to have 9 and 6. I want the 9 to be positive, the 6 to be negative. If I check inside outside, this gives me negative 6, positive 9. Again, negative 6 plus 9 is going to give me 3. Going ahead and using zero product property, I know 4 is not equal to 0. C plus 9 equals 0, giving me C equal to negative 9. And C minus 6 equal to 0 gives me C equals 6. So my solutions here are negative 9 and 6. And example number 5. As I take a look at example number 5, again, it is not set up in standard form. So the first thing that I have to do is move everything over. So we're going to move the 4v squared, the 8v, and the 2. And when I combine my like terms, I have 8v squared minus 2v minus 15 equal to 0. Looking for a GCF, it's always the first step. I don't see a greatest common factor here, so let's go ahead and try and solve this or factor this, and I think maybe I'll use the x on this one. What is 8 times 15? You should get 120, and that's going to be a negative 2. So what two numbers are going to multiply to negative 120 and add to negative 2? I'm going to come up with negative 12 and positive 10. So as I go to set my factors, I have v minus 12 for the first one, v plus 10 for the second one, but don't forget we have to divide by a. So I'm going to divide both of those by 8. Now I'm going to reduce. 12 over 8 is going to reduce to 3 over 2. And 10 over 8 is going to reduce to 5 over 4. Once they're reduced, I can go ahead and do bottoms up. So 2v minus 3 and 4v plus 5. Now I have it in factored form. And now I'm going to use the zero product property to solve each of the factors. So 4v plus 5 equals 0. And I'm going to add 3 to both sides first. Divide by 2. So v is equal to 3 over 2. Over here, I'm going to subtract 5 and divide by 4. So v is equal to negative 5 over 4, which makes my solutions negative 5/4 and 3/2. And example number 6. As I take a look at example number 6, again, please first move everything over to the left so that I have my quadratic set equal to 0. So add 2x squared and subtract 4x. So that's going to give me 6x squared plus 7x minus 3 equals 0. I want to set this up for factoring, so I'm going to go ahead and make my x again. 6 times 3 is 18. So negative 18 over 7. What two numbers multiply to negative 18 and add to 7? I want to use a positive 9 and a negative 2. As I write my factors, that means x plus 9, x minus 2 equals 0. Again, divide by a and reduce. So that gives me 3 over 2 and 1/3. Now I'm going to do my bottoms up. So 2x plus 3, 3x minus 1 equals 0. And set each factor equal to 0 with the zero product property. So subtract 3 from both sides and divide by 2. So x equals negative 3 halves. Add 1 to both sides and divide by 3. So x equals 1/3. So my solutions are negative 3 halves, comma, 1/3. I'm going to go ahead and pause this and pick it up in just. Okay, I'm back. And we're going to look at example number 7. It says we can solve this quadratic using both methods we've learned. So what are the two methods we've talked about? We've talked about factoring. So if I were to factor this, I have to find a pattern because I only have two terms. So if you can remember, this is what we call a difference of squares. Where basically I'm taking the square root of the first term, so the square root of 9 is 3, and the square root of the last term, which is 7, and I'm going to have one quantity that is 3x plus 7, and the second quantity, which is 3x minus 7. Now I can use my zero product property and set each quantity equal to 0 and solve them separately. So subtract the 7 and divide by 3. And over here, add the 7 first and divide by 3. So my solutions wind up being plus or minus 7/3. The other method that I have for solving this is the square root method that we learned Tuesday, where I take 9x squared minus 49 equals 0 and start by adding 49 to both sides. So 9x squared equals 49. Now dividing by 9, so I have 49 ninths. And then finally taking the square root of both sides. So I have x equals, and don't forget the plus or minus, 7/3. You can see that I have the same answer, and you can write them together or you can write them separately. It doesn't make any difference. So two choices, two different ways that you can solve this particular problem. Number 8, where it looks very similar to what we just saw in example number 7, it's got one distinct difference. When you look at this term here, notice that this one has an x compared to what you saw in example 7, where this term does not have an x. So keep that in mind, that it distinguishes between these two different terms, and that's going to make me think differently about how I go to solve this. So for this example, I'm going to solve by factoring. And specifically, I'm going to take out a GCF. So if I look at these two terms, the only thing that I see that they have in common is a GCF of x. So if I take x out, I have 16x minus 25 equals 0. So I can go back and say, oh, x equals 0, or 16x minus 25 equals 0. And to finish solving this one, I'm going to add 25 to both sides, divide by 16. So x equals 25/16. So be careful, I'm not taking the square root of these numbers, even though they look really inviting. My solution then is 0 and 25/16. All right, when I look at these last 4 examples, the idea is I want to choose the method, the best method to solve each quadratic. There's going to be an easier way and probably a harder way. You're usually going to have more than one choice. As I look at example 9, the two things that I see here is I could either solve this using a difference of two squares by factoring, or I can solve by using the square root property. I'm going to set this up for the square root property. To me, that's what's easier. So I'm going to subtract 24 from both sides, giving me 100 x squared equals 36. I'm then going to divide by 100. And if you use your calculator to do the division, I'm certainly not going to get upset about that. And that's going to give me 9 over 25. And now I'm going to take the square root. And the square root of 9 is 3. The square root of 25 is 5. Don't forget plus or minus. So my solution here is plus or minus 3/5. Looking at example number 10. Again, I can see that this is not in standard form, so the first thing that I want to do is move the 18x over. So now I have 64x squared minus 16x equals 0. Now, the only way that you've learned how to solve this is by factoring. So I'm going to go ahead and factor this. And again, I am looking for a GCF. GCF here is actually 16x. So if I take 16x out of the first term and 16x out of the second term, 16x is on the outside. 64 divided by 16 is 4. I'm going to count down on the x's. And this is going to cancel, leaving me with 1 equals 0. So now at this point, I can set each part equal to 0 with the zero product property. 16x equals 0. 4x minus 1 is equal to 0. So divide by 16, and I have x equals 0. Add the 1 over. Divide by 4. So x equals 1/4, giving me solutions of 0 and 1/4. All right, example number 11. Again, take a moment and analyze this question and decide which would be the best way to solve it. Notice it's not in standard form. So the first thing that I'm going to do is add the 4x over to the other side. This gives me 81x squared plus 4x equals 0. And whereas both 81 and 4 are perfect squares, because this is a plus, and I have the x in both terms, I know that the only way I can solve this is by looking for a GCF. And my GCF here is x. So again, I'm going to divide both of these by x. X is on the outside. 81x plus 4 on the inside. Using zero product property, set each part equal to 0. That one is finished. Move the 4 over to the other side. Divide by 81. So x equals -4 over 81, leaving me with a solution set of -4 over 81, 0. And for our last question, again, I need to set it equal to 0, so I'm going to subtract the 3x and the 2 over to the other side. So I have 9x squared minus 3x minus 2 equals 0. And I'm looking for factors for this one. So let's see. 3 times 3 is equal to 9. And if I make this a 2 and a 1, here I have a 6 and a 3. So this needs to be negative. This is positive. -6x plus 3x will give me the -3 I need in the middle. So I have it factored. Set each term equal to 0. 3x plus 1 equals 0. 3x minus 2 equals 0. Solve them independently. Subtract the 1. Divide by 3. X equals -1/3. Add the 2. Divide by 3. So my solution is -1/3, 2/3. And there you have it. I will see you in class tomorrow.